so I'm going to use this example to run through how to do implicit differentiation. So the first thing that you have to notice is that we have an implicit function. So this is an implicit function. It's not explicit. It doesn't say like y equals. It's got y and x on the same side. So that's basically the first tip off, that you have an implicit function. First thing that you're going to want to do is differentiate both sides with, in this case, with respect to x, because you're trying to look for dy over dx. So if it asks for dy over dx, that's kind of the hint that you're going to want to differentiate both sides with respect to x. So that's what I'm going to do here. So I'm going to differentiate this side. So remember, we're going to use this derivative operator. We're going to do it for this whole side. Okay, now what you do to one side, you equally have to do to the other. So I'm going to differentiate the other side with respect to x as well. Now the derivative operator actually distributes, so you can do the derivative of this y to the third with respect to x and the derivative of this x with respect to x. So that's what I'm going to do next. Okay, now the derivative of 3 with respect to x is just going to be 0 based on that constant rule. Okay, so the derivative of a constant is 0. Okay, now from here, we run into a little bit of a problem, because when you're doing the derivative with the derivative operator, the variables have to match. This y does not match this x. So what we're going to have to do is get a little tricky here. So what we're going to do, right, dy to the third. So I'm going to put this y to the third up here, and I'm going to divide it by 1, and then I'm going to multiply it by 1 over dx. So basically, if I multiply across, it ends up being the same thing as what we have right here, dy to the third over dx. Okay, I just put 1s here and kind of spread out this fraction. Okay, plus, now the derivative of x is just going to be 1. So I'm going to write plus 1 equals 0. Now again, the main goal of this is to figure out what dy over dx is. Okay, this is the derivative. This is what we're looking for. So we're trying to find dy over dx. So that should show up somewhere along the way as we're working with this. So the next step, what we're going to do is I'm going to replace these 1s here with dy's. Okay, and I know it's going to make more sense why I'm doing that in a little bit, but let's for right now just replace the 1s with dy here, and I'll replace it with a dy over here. Okay, these were 1s. Dy over dy will cancel to get 1 over 1, so it's perfectly legal that I'm doing this. Okay, this plus 1, I'm just going to subtract 1 to the other side. So we'll just do a minus 1 here, minus 1 here. So that cancels. So you have negative 1. Okay, now if you remember, our main goal is to find this dy over dx. Now, by spreading this out like I did, we end up having dy over dx. Okay, so we have to solve for this basically, but first we have to simplify this mess right here, this dy to the third over dy. Well, since the variables match, since the y matches this y right here, you can just do the derivative of y to the third because, again, because they match. So all we have to do is do the derivative and act like this is just x, so you're just going to use the power rule. You're going to bring the 3 down and minus 1 from the power. So I'm bringing the 3 down, minusing 1 from the power. So this right here is basically going to be equal to this part right here. So the derivative of y to the third with respect to y is 3y squared. This dy over dx is just going to be brought down as well because I didn't do anything with that. Equals negative 1. Okay, now if you remember, the whole goal is to solve for dy over dx right here. So we're basically solving for this. So what I'm going to do is divide both sides by 3y squared. And you end up with dy over dx equals negative 1 over 3y squared, and we end up solving for what we're looking for, which is that dy over dx. So that's basically an example problem involving implicit differentiation. If you have any questions about anything in this video, let me know.